Alright, good evening everyone. So tonight we're going to take a look at this, which is a 3D printed Bahtinov mask that I used one of the generation tools to create and then print it out. So I'll wait to try it out on the telescope for the first time. So after that we'll take a look at how the software, where I got the software, how I generated it, and obviously when I printed it out. So let me go and stick it on the telescope. Okay, so here we are. We're on Vega, and it doesn't look too bad because I had it in focus from last night. I'm just going to zoom in if I can remember how. Let's move this out of the way and move it to 1:1. And there we can see the diffraction spikes are the middle one's pretty central. So I just wonder if I can knock it just a fraction. I'll do it with the screen. So if we go into the focuser, and we've got step size, let's change it to 1. And we're still on 2-second exposures, I think it is. So let's just see what happens here. Neighbour's dog obviously doesn't like the noise. Well, I think that looks pretty central to me. So I would say that Bahtinov Mask works, which is brilliant. So let's head back inside and we'll talk through the software and how I got to where I am. One thing I have noticed when I put it on the scope though is I've actually got the size wrong, so it doesn't sit on the face of the OTA. It actually sits right on top of the main objective glass, which we don't want, but I'll print out another one the right size. Okay, let's head over to the computer inside.
Okay, so here's the mask that I had at the beginning of the video, printed on the Anycubic Predator printer, which if you look in the background here, it's the floor standing one, and the one that sits on the desktop there is Anycubic Mega S. So I used the Predator as it's got a larger build plate. I think it's up to 370mm in diameter. So first thing we want to do is head across to GitHub. We want to pick up the AstroJargon repository from Farmer Dave, and on the page there you'll see some basic information around the tool, and on the right hand side you'll see the releases. So we can click on the current version release, which is 0.4. and you'll be able to download just by clicking on the AstroJargon Mask Generator.zip. So this isn't an installer, it's just a straightforward zip file, and we can just extract that into a folder of our choice. So downloaded that, and I've extracted that into my general telescope related stuff here. There's the original zip, and there's the Mask Generator software. So it's built in the .NET framework from Microsoft, so you do need version 4.6 installed. If you don't know if you've got it installed or not, the best thing to do is just double click the exe file, and then it'll tell you if it's can be run or not, or you need to go and grab the .NET framework version 4.6, which is easy to find on the internet. So if we run up AstroJargon mg.exe, and we can see there is the basic Bahtinov mask, and you can go up to the top left Let me just make this a little bit bigger. And up to the top left you can create different types of masks. So the only two that I know is the Bahtinov mask, which is your standard focusing mask, and then we've also got this TriBahtinov mask, which allows you to also do collimation on your scopes, although I've never tried it, and that's maybe one for a different day, so I'm going to close that one just now. So taking the Bahtinov mask template there, on the right hand side we can set the properties. Now for the Edge11, as you know, I've already got this one here which I printed off for a 1960mm focal length, and I'm going to create another one now for the full native 2800 millimeter focal length. So to do that, we're going to go into the basic section and we're going to enter 2800 millimeters, and we know that the aperture of the telescope is 279 millimeters. And then we've got this overhang area, so this is up to you on how you want to have the mask mounted on the front of your telescope. So on the Edge11, I measured it at just around about 305 millimeters. So the overhang measurement is actually half of this, so this is at each side. So we just take the 305 minus the 279, which gives us 26 millimeters, and we divide that by 2 to give us the overhang of 13. Then we know that we've got the centre primary mirror on the edge, so we've got a knockout. So we set that to true, and then I'm using 100 millimeters. I measured it for the centre knockout. If you want to do mounting holes, is depending on how you're going to be mounting it as well. You know, you need to think about that. So I'm not going to actually put any mounting holes in the final print. What I'm going to do is just create a couple of little cylinders that I can grab a hold of. But to get the equal spacing on there, I'm actually going to use the mounting hole as the reference point, and you'll see that when we transfer it into the actual CAD software. So the mounting hole diameter doesn't really matter, and I'm going to do mounting hole count is going to be 3, and that'll give us 3 equally spaced around the overhang. And I'm not going to touch anything else except the margin. I can't remember if that has an impact in the positioning on the CAD software, so I'm just going to leave it at 0. And the rest of the stuff, Bahtinov factor and all that sorts of things, I'm not going to change. Everything seems to be fine as it is there. So I can just click play to generate the mask, and then we can go up to the save icon, and I'm just going to pop it on the desktop, 100 millimeters, and we click save. Okay, so that's just finished in the generator tool, so we can come out of that. And the next thing I'm going to do is go across to Tinkercad.com. Again, I'll put these links in the description. And I'm already logged in, and I've already got my astrophotography project folder. So this is everything that I've created to do with astrophotography, from prime focus adapters to Nikon Z mounts to all these various loss Monday to miniscope clamps and various other things. And then this is the one here on the top left, that's this mask here. So we're going to create a new one, so just click new 3D design, and just Tinkercad is free, so there's no need to worry about that. And the first thing we're going to do is click import, and we're going to choose the file that we saved, which is an SVG file out of the generator, and it's 100% scaling. We're just going to choose the artboard as the center point, and you can see the dimensions there is the 305, which is what is the correct measurement I am targeting. So I just click import, and this takes a few seconds, so just leave that to run. Alright, so there's loaded the model. I'm just going to zoom out with the mouse wheel, and at the moment the default thickness that it generates is 10 millimeters, so we're going to change that. Now I found that 3 millimeters is fine, so I'm going to drop that down to 3 millimeters. And just to make sure that the inner hole is the correct dimensions, I'm just going to create a cylinder of 100 by 100, and I'm just going to make it fully round and even, and at the moment the view is in perspective, so I'm going to switch it to orthographic, and now I can centre these two things. So if I click the alignment tool after highlighting both objects, click the mask as the centre reference, and then I can just click the two end stops, and we can see there that that's inner diameter is the correct measurements. Okay, so I can close that, delete that cylinder as it's no longer required. Alright, so there we've got our 3mm thick Bahtinov mask. So as I said, I wanted to just put a couple of cylinders on the holes. So I'm going to create a cylinder, I want it nice and smooth, and I'm going to just make this 10mm in diameter, and its default height in Tinkercad is 20mm. Let me just drag this model out of the way here, and yeah, 20mm, so that'll be fine. So now I'll just drag these to roughly where the centre is. Unfortunately there's no easy way in Tinkercad to align it other than just to eyeball. So that's exactly what I'm going to do now. At the moment I've also got the grid set to 1mm, which probably isn't helping, so let me just drop that to 0.5mm. Let's see how that is. That's not too bad there, and it's probably good enough for these purposes. So I'll just create another copy of them, Control C and Control V, and then drag them over and just have a quick check underneath and just position until I'm happy that that looks relatively centre. And that'll do. Alright, so now that's me created the mask in Tinkercad. So it's just a case of now of exporting that. We want the full, first thing I want to do is select everything and group objects so that everything becomes merged as one object. And we're satisfied that the cylinders are down to the bottom of the mask there, and there's no hole going to appear, and these aren't going to be floating on the surface. Alright, so now we can export this mask as an STL file, and it comes up with these random names, but you can change them as you see fit, which I'll do once I'm finished. And the next thing I'm going to do is, I've just clicked on there, which will default to open Ultimaker Cura, which I use, and of course you could just load that in from the download. So that's opening up now. And it's opened on the other screen. Alright, so I'll pull that across. Let me just size this so you can see it and I'm not obstructing anything. Alright, so there's the model being dropped onto the centre. Now I've set up Cura with these models of the printer so that I can see where it sits on the bed plate. So I've got my Anycubic Predator set up there, and I'm just going to use 0.2mm, and it's come up with suggested changes based on the thicknesses, but I run the temperature slightly higher, and the infill density I'm going to reduce that down to the 15, so I can just check 0.2, and infill density I'm going to set that to 15. And the printing temperature is sitting at 205, and the bed temperature is 60 degrees normal, 65 for the base layer. And now we can hit the slice. So that's it generating the model there. Let's just move this up away, and it says it's going to take 12 hours to print this large mask out at those settings. Now you can obviously tweak around things like layer thicknesses and infill densities, etc. until you get the conditions that you want, and you maybe print some smaller, thinner ones off as a trial, just to get your dimensions correct rather than wasting plastic. But based on the current prices that I've got set in the unit, it's going to take €1.45 of plastic to print off this model at that current spec. So if I hit preview, we can see exactly how it's going to print the model off, and I can just satisfy myself that everything looks okay, there's no holes, no gaps, and everything looks fine. And if I flip it over, and I can check everything that yellow is touching the bed plate, which is good. There's no holes where I've put the standoffs. So it's just a case of now of exporting that to the printer and generating another one. Okay, so I've just turned on the printer and I've hit preheat just to get some temperature up while I'm exporting it. So I've inserted the SD card from the printer onto the computer, and I'll just do save to removable drive, which is currently coming up at drive G. And that's it finished. So I just need to remember the model name is AP Stunning Esbu, and just eject that. And that's it ejected, so I can remove that now. SD card, pop it into the printer, and I can select print Stunning Esbu and hit print, and we'll see what it looks like in 12 hours time. We'll catch you later. Alright, so it's the next morning, excuse me, and the printer has finished printing. So it took a total of 11 hours and 4 minutes according to the printer. So I'm going to stop that, turn it off, get rid of the noise, and we'll remove the print off. Let's come away, no problem, now that the printer's cooled down overnight. Alright, so here's the mask that we printed out, and you can see that just the handles that I put on there just to help lift it off the OT. And now we just need to do a little bit of cleanup just to remove the strings. Overall, it's come out pretty well. The top surface looks okay, and just the usual couple of minor blemishes on the bottom where it hasn't adhered to the bed plate of the printer straight away. So the first thing I'll just do is I just need to remove this brim, which I've set up on the printer around any object just to help the adhesion for the initial layers and to hold the part in place. And now we just need to remove, you'll see there's a couple of stringy bits just for the way the printer's moved around to do the print. So I can simply peel them off with a craft knife or a little bit of sandpaper, and then we can try it out on the printer, on the telescope once it gets dark. So one of the tools that I do have for 3D printing is this deburring tool. It's basically a slightly curved blade, and I just run that around the edges just to pull out the stringy bits and just to smooth off, and then I'll just give it a quick rub down with one of the fine grade sandpapers just to remove any potential sharp edges and things. So as I say, we'll just wait for it to get dark now, and we'll see how it fits on the telescope. So I'll catch you in a bit.
Alright, so we're back inside the dome, and here you can see I've currently got Vega in the capture, and that's sitting with the 1960 Bahtinov mask that I had previously made. So the one earlier in the video was the 2800mm Bahtinov mask, so we're going to convert the telescope over to the full native 2800 by dropping out the 0.7 reducer, and then we'll put on the 2800mm Bahtinov mask that I printed earlier. Okay, so first off we'll drop out the reducer. Let's take so this is the 2800 Bahtinov mask, so I'll take off the 1600 one. Alright, and there we can see a well out of focus star, so we can now try to get as close in to focus as that. Alright, so that's going the wrong way, so let's come down the way. Alright, so let's go 22,000 for this last big step. And that got bigger again, so we know we need to be up the way. So starting with a step size of 50, let's just keep nudging it in. Let's do 5 times 50, so it's 250. Okay, we're getting close here. That's down to 22,810 steps. That's maybe just gone bigger again. So let's put the mask on now. So okay, let's let everything stabilize. Alright, so you can see it's a little bit to the left. That's moving to the right, so I want to go the other way. It's getting better. So that's pretty close to central, so we'll drop the step size down to just 1 and see where we go here. Now I would have said that's maybe approaching center there. Keep nudging it. Alright, and I think I would go with that, going by the top and the bottom. So I would say that's in focus. So let's take off the mask again, or sorry, let's just go back to fit the entire image in the window and take off the mask. Alright, leave that to stabilize. Okay, good. And so this is still 1 second exposure, so let's just do a quick 10-second exposure. Let's zoom in. No, that doesn't look too bad. Maybe a little bit of tweaking here and there. But overall, so that's it. That's the 3D printed Bahtinov mask. Another success, I would say. So that's all I've got for just now. That just finishes off this one. Thank you very much for watching, and we'll see you in the next one.